guys! In today's video we are going to talk about logarithmic functions. Logarithmic functions are really cool. Sometimes they seem scary at first, but the more you practice with them and the more you understand them, the cooler they become. And they actually might become your favorite thing that you learn in mathematics. So let's think about this problem. How many times would you have to double $1 before you had $8? So let's put that on here. How many times would you have to double $1 before you get $8? Now, you can probably solve this using mental math. You start with $1, then you have $2, then you have $4, and then you have $8. So we had to double $1 3 times. 1, 2, 3 times. So you could probably figure that out using mental math. You could have used this equation, 2 to the x equals 8. So we're doubling, so that's our base. And what exponent would we have to raise this to get to 8? Oh, that's the third power. Well, what if it gets a little bit trickier? What if we want to know how many times you'd have to double $1 to get to $512? That's not as easy to solve using mental math. And that's when we want to use the operation called a logarithm. A logarithm is the exponent to which a specific base is raised to obtain a given value. What the heck does that mean? Let's write it down. That way we can analyze the statement. A logarithm is the exponent to which a specific base is raised to obtain a given value. What does that mean? Oh, I think that means that the logarithm is used to figure out a given value. And that value is the exponent. So we could use a logarithm to figure out this exponent. So we can write an exponential equation as a logarithm. We can also write a logarithm as an exponential. So let's write down what we know about exponentials. So let's do an exponential equation. In our exponential equation, we're going to have some base raised to some exponent equals some value. Well, a log equation, I'm just going to write log on there. So a log equation is going to be a specific base raised to obtain a given value. And so we're going to have our log here. Our base is going to be a subscript of the specific value equals our exponent. That's how we're going to get our exponent. So let's practice converting between exponentials and logs. So let's practice converting between exponentials and logs. So we're just going to practice this. Okay. Well, let's say we have 2 to the 6th is 64. Well, that's true. 2 times 2 times 2 times 2 times 2 times 2 is 64. How would I write this as a log? Well, let's match up colors here. Our base is 2, so that should go right here. Our exponent is 6, and so that should go right here. And our value is 64. And so we could write this as log base 2, 64 equals 6. Yeah, these are equivalent statements. Both of them mean exactly the same thing. Let's try another one. 4 to the first power, well, that equals 4. 4 to the first power equals 4. How can I rewrite this using logs? Well, my base is 4, my exponent is 1. My answer is 4. So if we look at this equation here, it's always going to be the base that goes down here, the answer that goes right here, and the exponent that goes over there. And we can remember that because we use logs to solve for the exponent. Ah, this is awesome. Let's try another one. 5 to the 0 power. What is 5 to the 0 power? Oh, it's 1. Anything to the 0 power is 1. How do I rewrite this as a log? Well, let's first identify our base. Our base is 5, so we're going to write log base 5 of 1 equals our exponent is 0. That's pretty cool. What if we have 5 to the negative second? Well, 5 to the negative second is just 1 over 25. We know that because of the reciprocal rule. We know, if we did a little side note over here, the reciprocal rule says that any negative exponent, you would hop the bar and switch the sign. So the 5 is attached with that negative exponent, and so this actually becomes 1 over 5 squared. Well, 5 squared is 25. Well, let's rewrite this. So we know our base is 5, so log with a base of 5. The answer was 1 over 25, and our exponent was negative 2. Are you guys seeing the pattern here? The base is always this number. The answer is always this number. And the exponent is always what the log equals. What if we have a variable in the exponent? 3 to what power equals 81? Well, my base is 3. The answer is 81, and my exponent is x. Look, we just solved this equation for x. That's pretty cool. Now we know how to solve for x when x is an exponent. Why don't you try a few? Go ahead and pause the video here and try to rewrite those on your own. Okay, let's check our work. If I want to rewrite this one, my base is 9, so I'm going to have log base 9. The answer is 81. And this is going to equal 2 because that's our exponent. The base here is 3, so we're going to have log with a base of 3. The answer was 27, and our exponent was 3. Our base here is x, so we're going to have log with a base of x. Our answer was 1, and the exponent was 0. And there we have it. Logs are the inverses of exponentials. And what that means is really they're opposites of each other. So what we just did was we practiced going from exponential form to log form. Well, we can also go from log form to exponential form. So let's try it out. Let's start with something in log form and let's transform it to exponential form. So let's say we have log base of 10 of 100 equals 2. How could I rewrite that as an exponential equation? Well, our base here is 10. This is our exponent. Remember, whatever the log equals is your exponent. And there's our answer. And then just double check, does this make sense? Is 10 squared 100? Sure is. So it makes sense. Let's try another one. Log base of 7 of 49 equals 2. Well, we know our base is 7. Our exponent is always on the other side. And 7 squared is 49. Let's try another one. Log base of 8 of 0.125 equals negative 1. 0.125 is the same thing as 1 over 8. So our base is 8, our exponent is negative 1, and it equals 0.125, which we know is true because 0.125 is 1 over 8. This is really cool. Okay, what about log base of 5 equals 1? Well, our base is 5, our exponent is 1, and sure enough, 5 to the first power does equal 5. And let's just do one more. Log base of 12 of 1 equals 0. Our base is 12, our exponent is 0, and sure enough, it equals 1. You try a couple. Try log 10 of 10 equals 1. Log 12 of 144 equals 2. And log of 1/2 8 equals negative 3. Pause the video here and try these on your own. Let's check our work. Well, our base is 10, our exponent is 1, and the answer is 10. And does that make sense? 10 to the first power equals 10. Perfect. Our base here is 12, our exponent is 2, and 12 to the second power sure is 144. Our base is 1/2, our exponent is negative 3, and it equals 8. And if we think about our reciprocal rule, that is true. Because you would hop the bar, switch the sign, so the 2 actually comes up top and it's 2 cubed, which is 8. And there we have it. Okay, let's practice evaluating some logs. What does the word evaluate mean? It means to find the answer. So let's say we have something like log base of 2 of 8. What does that equal? We want to figure out what that equals. How do I solve that? Oh, I could rewrite it as an exponential and have 2 to what power equals 8. And now I can use mental math and solve this. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. And so log base 2 of 8 equals 3. Well, that wasn't so bad. Let's try another one. Log base of 4 equals 16. No, it doesn't equal. Log base 4 of 16, and what does it equal? Well, I could do the same thing and rewrite it as exponential. 4 to what power equals 16? And then I can use mental math and try to solve this. 4 to the first is 4. Oh, 4 to the second is 16, so this has to equal 2. Let's do a few more. What if we have something like log 3 of 1/3? What in the world is that going to equal? Let's do the same thing. 3 to the power of what equals 1/3? Well, it can't be 1 because 3 to the power of 1 is 3. It can't be 2 because 3 squared is 9. And as I increase my exponent, my numbers are getting bigger. So I'm going to have to decrease my exponent. So 3 to the 0 power is 1. 3 to the negative first power, well, 3 to the first power is 3, and the negative means I make it a fraction, so it's 1/3. Oh, that's awesome. So this has to equal -1. Let's keep on trying some. What about log base of 4 of 1/16? What does that equal? Set it up the same. 4 to what power equals 1/16? Well, I know 4 squared equals 16. So if I make that squared negative, it'll make it a fraction. So this has to equal -2. Let me give you a few to try. Try out log base 2 of 4, log base 5 of 125, and let's do log base 6 of 1/36. Pause the video here and work these out on your own. Okay, let's see what you got. So log base 2 of 4 is 2 because 2 squared equals 4. Log base 5 of 125 is 3 because 5 cubed is 125. And lastly, log 6 of 1/36 is -2 because 6 to the -2 equals 1/36. Let's spend some time talking about special properties of logs. So we've got a few of them. And I'll just write on here special properties of logs. And my special properties of log, well, the first one is if I have a logarithm of base b. So if I have log base b of b, this always equals 1. Every single time. If these numbers are the same, it equals 1 because b to the first power always equals b. We could throw some examples on there. What is log base 10 of 10? 1, because 10 to the first power is 10. What is log base 4 of 4? 1, because 4 to the first power is 4. And that will work every single time your base and your argument are the same. Let's look at another special property of logs. What if we have log of any base and the argument is 1? What is that going to equal? What I mean is b to what power always equals 1? 0. It doesn't matter what the base is. if you raise it to the exponent of 0, it always equals 1. And so we can do a couple of examples of this. What if we have log 10 of 1? That equals 0, because 10 to the 0 power is 1. Or log 3 of 1. Still 0, because 3 to the 0 is 1. Pretty cool. If your log has a base of 10, we call it the common log. So the common log is a log with base of 10. When the log has a base of 10, we don't always write the base there. And so what I mean by that is if you have something like log 5, log of 5 is the same exact thing as log base 10 of 5. And so these are exactly the same thing, and you don't have to write that base 10.